31.
Tangent of x over cosecant squared over x.
Tangent of x over cosecant squared of x.
Plus tangent of x over secant squared of x.
Okay. One thing we could do here is get a common denominator if you're thinking that, right? I'm not going to do that though. Because, so, just talking about like what I see here. If I have over cosecant squared here, I can move that to the top. What's it going to become? A sine squared. Does that make sense? Like this fraction here is the same exact thing as tangent of x times sine squared. Again, as long as it's all multiplication and division in one fraction, you can move things up top, down the bottom, doesn't matter, but they change, right? Cosecant on the bottom is sine in the top. Yes? You could make the tangent sine over cosine. Look, there are many ways to do this. I'm showing you the one that I think is the fastest. Okay? You could do sine over cosine and work all that out. But the benefit of me writing it like this, and look, you guys should be on the lookout for this. Do you see the sine squared and the cosine squared? You see them both in there? Hopefully, yes, they're right there. We're adding them together, but what do they both have attached to them? Tangent. So guess what we can do with that tangent? Factor out tangent, which just leaves us with sine squared plus cosine squared. And that's just 1. So this just equals tangent of x. How nice is that?
What?
No, right? So look. Hold on. Can we go back real quick? I'm going to redo this problem a different way because maybe you don't notice that right away. But again, I'm trying to highlight the keys here to see this. Like a cosecant squared by itself and a secant squared by itself in the bottom. I just noticed when you move them up top, you're going to have a sine squared plus a cosine squared. It's just going to happen. And I'm looking for that as I do this because I know that's an easy rule. Okay? But let's say you didn't recognize that here. So let's do this. Can we do this? Oh, I know, right? Technology. Ooh. Okay. So let's say you didn't recognize that, and someone said, let's switch to sines and cosines, which I promise you will always work. It's just not always the simplest thing to do. Okay? But this is how, if you rewrite this first fraction in sines and cosines, check this out. It becomes, the tangent is a sine over a cosine, right? So it looks like that. And again, because it's all multiplication and division, I don't have to make separate fractions. I don't have to make it sine over cosecant squared. The cosecant squared is just down the bottom with that cosine. That makes sense? But cosecant down the bottom is the same thing as sine squared up top. Can we handle that? That's how that first fraction gets rewritten with sines and cosines. Again, you can make it complex fractions and everything all you want. It's just going to be more work. This second one then becomes sine x over cosine x. That's the tangent. And secant squared really puts a cosine squared up top. Can we handle that? And then we can just simplify things down. Okay? Well, actually, we have a common denominator right now, right? And we're probably going to put it together. So rather than simplifying, so look, sometimes students will do this. They'll see the cosines over here, and they'll say, oh, I can cross them out. But then you lose your common denominator, and then the very next thing they do is they get a common denominator. Okay? So, again, don't rush blindly into these things. Think about what you're doing here. Okay? We got the common denominator. We're going to put them together, and you can see the same thing's going to happen that happened the other way we did it. It's going to be sine of x times sine squared. Well, we can make that sine cubed, right? So maybe you see that. Plus sine of x times cosine squared all over cosine. And I gave you all these things to do. If you're stuck here, you go through your list. And we can factor this out. We can factor out a GCF. We can take sine out. And if we take sine out of the top, you're going to be left with sine squared plus cosine squared. That's a squared. Over cosine. But that's sine squared plus cosine squared is 1 again. So we just get sine over cosine, which is tan. The same answer. It doesn't matter how you do it. You're always going to get the same answer. Okay?